This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make wind turbine lightning protection easy. If you're a wind farm operator, stop settling for damaged turbine blades and constant downtime. Get your uptime back with our Strike Tape lightning protection system. Learn more in today's show notes or visit weatherguardwind.com/striketape.
Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime Podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back to the Uptime Podcast. I'm your co-host, Dan Blewett. On today's show, we've got a bunch of interesting trends from the news world this week. Number one, the world's tallest turbine was built in Germany, so we'll talk a little bit about the engineering there. Offshore blades are getting bigger. We're going to talk a little bit about the Siemens Gamesa's new 108-meter blade, which has a couple interesting features that we want to talk through. We'll talk about global wind turbine commissioning, which was actually up by 59% in 2020, which is pretty crazy considering we had a pandemic. It was an insane year for everyone in every industry, but apparently wind energy did pretty well. We'll also talk about a really interesting bird deterrent system from Digisec, some interesting vertical axis wind turbines potentially being installed at the O2 Arena in London, and a couple other little items. So, Alan, let's start with Germany and this incredibly tall wind turbine. So, Max Vogel Wind AG has installed the world's tallest turbine in Stuttgart, Germany. Hub height of 178 meters, total height of 246.5 meters. That's really tall. That's
it is really tall.
Yeah, God's hey, get this out of my backyard. Like, what are you guys doing?
Right. It's really tall. But the technology is sort of a combo between wind energy and water storage, like a water storage battery, where the bottom of the wind turbine is actually a water tower. So they're pumping water into this tower, and then when they need energy, they pump it out and create electricity. So it's like a water storage battery, which therefore increase the heights of the turbine. So the turbines they're GE turbines, right? They're GE turbines, like 3 megawatt turbines on top of this water tower structure, which is a very interesting concept because you're kind of combining two technologies into one and trying to utilize the best out of both of them. It just got to wonder what the mechanical stress loading is on something that tall, which is being pumped full of water and then drained of water all the time. You kind of think that's a really significant engineering project to accomplish. I'm surprised that they could pull it off because I haven't seen this anywhere else. Have you seen this anywhere else?
No, this is the first one. No. But it's interesting. Yeah. I mean, kind of in the same vein as the offshore platforms where they have, there's a offshore wind turbine, and then they have an aquaculture lab. Like, they've been talking about all these different ways to combine stuff, right? And this seems like the same kind of thing, which is cool, right? They're combining water energy storage and obviously a wind turbine. So
right.
It's pretty. I think it's pretty neat that they're trying to maximize the use and get more out of the same footprint.
Well, it will be fascinating to watch as it progresses to see if the combination it does pay off in the long term. That's what everybody's going to watch, right? They're going to make sure that if this is a realizable combo, then why are other companies picking up on it and doing it? So they need to demonstrate very high efficiency and reliability with the system. If they can do that, you think they'd be trying to do this elsewhere. So it's that first engineering step where you try to do it on a smaller scale in terms of the number of turbines, and then if it works, you explode it, right? You go from 10 turbines to 100 turbines to 1,000 turbines to 10,000 turbines, because that's the right way to do it. And you kind of wonder on the offshore side too if it makes sense on the offshore side to do that, because obviously you have access to seawater. Do you pump it in, pump it out as part of a water battery storage system? It's a really interesting concept, but we haven't really seen it anywhere else, especially integrated into the turbine base or the hub, or not the hub, but I mean the tower. We haven't really seen that at all.
Yeah. Cool. Well, I've heard Disneyland is going to come out with a 500-meter turbine with a cyclonic roller coaster going up and down. You'll get real close to the blade tips, and then no, that will never happen. But actually, that would be pretty cool. I mean, if it was tall enough, you could, just have it at the bottom, a little
Yeah.
bungee jumping station, whatever. Do all sorts of stuff. But I digress. So moving on, the Siemens Gamesa B108 blade, which is 108 meters long, which will be installed on the aptly named SG14222DD, which is their 14 megawatt offshore
Direct
turbine
drive.
that we always make fun of because of the name. But this is a really interesting blade, A, because it's gigantic, but B, there's two big pieces of technology that they highlight on it. Number one is their Power Edge technology, which is just a leading edge solution that they're installing in-house, that they're developing in-house. And they're explaining it on their website that at a tip speed of 90 meters per second, which obviously as these get bigger, the tip speeds increase. They said this is just going to destroy leading edges. So we've got to reinforce these to a significant degree. So, obviously they're not going into what this Power Edge technology entails, because obviously everyone's super secretive in the industry, but any thoughts, any speculation on what they're doing to reinforce such a blade?
It sounds like a polyurethane solution, just reading it about it at the top level. Very similar to what happens on aircraft and what other companies are offering right now. So polyurethane's a pretty durable material, stretchy, compliant, can take rain impacts, multiple rain impacts fairly well, not perfectly well, depending on speeds. They do degrade over time, or have shown on the aircraft side to degrade over time. You need to replace them once in a while. They tend to, one of the failure modes is they tend to yellow, or a little bit UV sensitive. So that you got to keep an eye on it. But I think as you pointed out, one of the unique features is that no one's really talking about what this thing is. None of the wind turbine companies actually talk about what their technology is. If it's patentable, then clearly they have a patent for it. So, it takes all of 2 seconds to go on Google Patents to find out what it is.
Yeah.
or to describe it. I think that's one of the disappointing features about this wind turbine industry, is that they don't provide any sort of YouTube video, analysis, data, test reports, anything on what these pieces of the turbines, these quote unquote commercial pieces of the turbine are, or how they perform. You're just supposed to read the literature. And as we've seen time and time again, if you go back and look, especially at promotional material for wind turbines, they don't add up to what actually happens in the field. So it's it's just commercial PR work, it seems like right now. Unfortunately, 'cause it may actually be great, but we just don't know. I think that's the trouble, is that you're in an industry in which has gotten beat up so bad by leading edge erosion, and yet we have an opportunity to correct that, and I'm not sure we provide the data to show that we've done it. It seems odd.
Yeah. Well, so the other feature that they're talking about, I mean, there's a couple, but the one that sticks out is that they have a industry-leading, quote-unquote, lightning protection system that it sounds like they put a lot of extra engineering into. Also, no real insight into what that might be.
Right.
But, I mean, from your perspective, what would be some of the things that would have to be included of a blade of this size? I mean, they can't necessarily have a one-piece down conductor, right? There's going to be a lot of different junction blocks probably in between. And,
Right.
I mean, if you were designing a lightning system for such a long blade, what would be key things that you'd make sure would be in the engineering?
Well, a blade of this size will typically have carbon fiber reinforcement as part of the spar or web.
And they mentioned
make
that,
it
yeah.
strong enough. Yeah. So that's going to drive a lot of the lightning protection design, because as we have seen in the past several years, there's been issues where the down conductor starts sparking over to the carbon fiber pieces of the blade, and then you have these fatigue failures later on. And so just a couple of features you want to be careful about. One is that the down conductor inductance isn't so high that you do get those flashovers. You want to prevent those flashovers. And I've seen a couple different approaches to that recently. But that's one problem you'd have to solve. The other one is just trying to prevent lightning strikes to the carbon fiber. That would be bad. It's really bad. So they tend to put some sort of metal foil over it to protect it. And then just the lightning protection system in general, how efficient is it, and is it efficient while it's rotating? I think that's right now it seems to be the biggest issue is while stationary, lightning protection systems work great. When they're moving at speed at 90 meters per second, not so good. So what has been done at speed to demonstrate that the lightning protection system is working? To my knowledge, zero. I mean, there's been discussions about it. There's been some master's thesis papers published about it in the last couple of years, but in terms of publicized data from the wind turbine companies, almost zero about it. And I think that's a real pinch point in terms of the technology and the lightning protection systems, that you can only test in the lab while it's stationary. And you really can't test it while it's moving, but the blades are moving at really high speeds. And like we have seen on airplanes, you get there's different physics involved when the blade or the aircraft is moving at speed. It's just not the same thing.
Well, do you want to talk about that? So obviously the concept of aircraft lightning zones, where it could strike in one, and as the plane's hurtling through space at 500 miles per hour, it's going to reattach in a different lightning zone, and then maybe even another lightning zone before it finally leaves the plane.
Yeah.
How does that relate to wind turbine blades?
Well, on an aircraft, if you think about an aircraft wing, how similar it is to a wind turbine blade, they're very similar in terms of shape, its performance, what it does, how they're designed. They're very similar structures. The difference between the two, mainly between the wind turbine and an aircraft, is pretty much all the pieces on an aircraft are conductive at some level. Either they're made out of carbon fiber or they're made out of aluminum. So everything's conductive on a wing. What you see on an aircraft wing as it's moving is that the lightning is following behind it, trying to, lightning attachment to a wing. Lightning's trying to reattach to the wing the whole time and try to hang onto that wing as long as it can. Everything on the wing is conductive, so it can sort of move inboard and outboard on the wing a little bit. On a wind turbine blade, it's a little bit different because most of the blade is non-conductive. It's made out of fiberglass or balsa and plastic resins, and very little of it is conductive. Maybe the carbon fiber spar cap is, and maybe the down conductor are the two things that are conductive. So where lightning wants to stay attached to is really dependent upon the aerodynamics and what the most attractive part of the blade is at that particular microsecond.
Yeah.
And it changes as the blade moves because the blade is moving typically away from the lightning strike, just like an airplane is, where on an airplane, lightning can find something else conductive to attach to. On a blade, it sometimes can't. And so because it has so much massive potential, the lightning strike can bore through a blade, no problem, to find something conductive to attach to, which is what it does. So the movement of the blade is critical here.
So is it true that, it could strike a really high point on the tip that's mostly fiberglass, that's not really that conductive, but then as the blade moves, maybe it exposes a portion farther down the blade where there's a carbon fiber spar, and be like, hey, this is a better spot for me to strike. I'm excited now, personifying lightning, but...
Exactly. No, I think you nailed it exactly. So as the blade... Typically, what I think is happening is that the initial lightning strike or the start of a lightning event to a wind turbine blade is when the blade is kind of mostly vertical, and it is probably attaching where you want it to for the most part. But then it moves away, right? The blade kind of moves away from where the lightning strike is. So the lightning strike is actually chasing the blade around the arc of the blade, and where it decides to attach is really dependent on a lot of unique physics to lightning. Lightning is not necessarily continuous. It pulses. It's just like this pulsy effect. So there are times when it's quiet. When I say quiet, there's not a lot of current flowing in it, and then there are times where there's a lot of current flowing in it. So if the lightning decides to go quiet for a brief amount of time, and the blade moves away from it, and then the lightning gets energetic again and wants to dump a bunch of current off somewhere, it has to create a new path to the blade. And if it can't find a very easy path, it's going to find the difficult path and take it and go right through the blade, right through the blade structure, which is what's happening. So that movement combined with the pulsy impulse of lightning strikes is creating a lot of damage on blades. And until the industry figures out that it's not a stagnant, stationary problem, then it's a aerodynamic, airflow, lightning protection issue, you got to combine aerodynamics and lightning protection together to make a solution, then we're going to continue having a problem. So we just are.
So let's move on. Let's go to Siemens Gamesa here. So interesting article about the offshore bidding rights and the prices for developing some of these offshore sites. So Andreas Nouwen, who is the chief executive at Siemens Gamesa, explained in a recent article that these prices for development are going up, which is going to in turn squeeze wind turbine manufacturers to reduce their
Right.
costs to provide turbines at cheaper rates so that
Right.
these projects can make sense. Alan, I mean, what do you see? I mean, is it just the fact that hey, we know there's more of these being developed, so the rates of these offshore land leases, if you call it land, obviously it's like, seabed. What's driving the prices up?
I think COVID is driving the prices up because there's a lot of investment cash that's sitting on the sidelines with no home, and I'll relate it to the Tesla stock price rise, to a lot of stock price rises, to a lot of investment, billions of dollars investment in some sectors that wouldn't otherwise have that kind of money in it right now. I think COVID really shut down the economies, but there's a lot of investor money still in play, and they need a place to deposit it. And so you're looking for opportunities, long-term opportunities that may be high growth. And one of those opportunities is offshore wind. And the first step in offshore wind is to get the lease to put the wind turbines out there. So it creates a sort of bidding issue, I think, between investment groups that see a potential in wind. You're right, Dan. I think there's a problem in that if you overpay for the lease itself, can you manage the downside risk of the turbine's going to be expensive, you're going to have maintenance issues, all the things that come with wind turbines. Can you manage that and have a profitable investment return long term? Who knows, right? But who gets clobbered in these situations all the time? It's the manufacturer. They just do, right? Because if you've poured a bunch of money into the investment into the property, where do you try to recoup some of that? You try to recoup it and keeping the cost of the turbines down, which means you're going to be super aggressive on driving down turbine prices, which, it's good in one sense that you have an opportunity to make a bunch of turbines, and it's bad in the other sense is that your profit margins on the turbine may go to almost zero out of the factory.
Kind of reminds me of being, the term house poor. Someone overpays for their house and they can't afford
They can't
afford the furniture, right?
Yeah.
They're just sleeping on the floor, et cetera. Obviously, that's a little of extreme example, but kind of reminds me of that. And the other thing that comes to mind is, this idea just like in Texas where maybe, and again, it's clear that not all these wind turbines in Texas needed winterization, right? It probably didn't make economic sense for some of them. Maybe it did for others, but when you start to look at all the things that you should maybe insure against by having maybe blade heating or maybe, this extra leading edge protection or vortex generators, all these other things you can add to protect your investment from losing AEP over time or whatever, you're probably going to start to skimp on them if you're a developer and you overpaid for your offshore seabed lease, right?
Sure.
Like, man, we got to cut costs. Let's not do the leading edge thing. Let's not do the bird deterrent thing. Let's not do the another great example is like fire traces. Fire suppression system. We probably won't need a fire suppression system. Let's cut all that stuff, then we can make the numbers work. Yeah. And that ends up being a recipe for a disaster too.
It does.
So, yeah, it'd be interesting to see how this all kind of gets negotiated out if the leases are really expensive to the point where it starts to make people nervous and want to start cutting corners, because that's not a good thing long term either.
Right. It hurts the industry long term is what it does.
So going forward, global wind turbine commissioning was up by 59% this past year in 2020, which I think is astonishing for everyone considering how rough of a pandemic year we had. 96.3 gigawatts of wind turbine power installed versus 60.7 gigawatts the previous year, and China commissioned 57.8 gigawatts of that. So that seems like a big chunk of it, obviously, with China sort of soliciting from all turbine makers. China's buying from pretty much all of them now. So, and noteworthy for Go USA, General Electric company and Goldwind. Of course, we shouldn't say Go USA because, Europe is powering so much of the green energy revolution, and our friends over in Denmark. I mean, go Denmark. You guys are great. Right. Like they've got all this going. We're just catching up, trying to do what America does. But GE and Goldwind were the top two turbine suppliers in 2020, unseating Vestas, which was number one in the past 4 years. So Alan, what strikes you about this report? Does this surprise you, being that it was crazy COVID times?
It does, but I think one of the industries that has been sort of COVID proof has been wind turbines, is in that the
Very social
construction projects.
distance.
Yeah, well, I think the construction projects have been continuing to ongo, even though there have been COVID restrictions. Depends what part of the country we're talking about, also, right? A lot of wind turbines down in Texas. Texas has had fewer restrictions, and so it would make sense that some of the places that had fewer restrictions on COVID are probably also developing wind turbines. That seems to be how it works right now. So you kind of get gung ho because your cost of labor may be relatively inexpensive. The cost of fuel is way down right now. So you want to, if all these things are fuel intensive, so you want to do it now because it's less expensive overall. So because your costs are more controlled and things are lower quote unquote prices, you may be incentivized to push ahead and try to get as many projects as you can done while things are cheap, which appears to be the case, right? And I think that's a sort of a good omen. I think when you look at potential growth in the world in terms of wind turbines, America is one of those places just because of the huge amount of coastlines and also the huge amount of open space that you can put a lot of wind turbines up instead of putting up in groups of 10, like it usually happens in Europe. You're putting up in groups of 100 in the United States. Same thing in China. They tend to be large groups of wind turbines. So the quantity of sales are higher by roughly a factor of 10, right? So each site in America is roughly 10 times the size of what it is in Europe. And if GE is trying to protect their home market, which would be America, and Goldwind and China are trying to protect their home market a little bit, that's why those two are growing faster than the others, is because they're playing on their own home turf. That's what tends to happen. So it is fascinating. It's grown so much in COVID times, but I do think if you're smart and you take advantage of the situation, this is what happens.
Yeah, no, that makes sense. I mean, like you said, there's been a lot of industries that have done very well in COVID, and of course,
Yeah.
no one's happy that they thrived in COVID. I don't think Peloton is, hey, love capitalizing on,
People at home.
awful world events. But, Peloton is another example of a company that did very well. So
Yeah.
anyway, so moving on. So the O2 Arena, which is a extremely busy arena in London, is installing vertical wind turbines made by Alpha 311, which we've actually mentioned them in the past. And I don't think made the connection before reading the article earlier this week, but they're the ones doing the vertical wind turbines that we mentioned on embankments or medians for highways. So trying to harness some of that wind power that's created by a car, driving by at 65 miles per hour. So they're going to be installing initially 10 of these wind turbines on the O2. I don't know if it's on the roof exactly, but they're going to be helping to offset some of their electric costs at the O2 Arena and perhaps install more of them in the future. And AEG, who owns the arena, is looking to install these at different venues around the world. So just another interesting development. And of course, these are vertical wind turbines, which we know have been sort of embattled in the past at different scales. These are pretty small, so they're 4 kilograms. But again, I mean,
Oh, wow.
maybe this is the right application. It sounds like these are very sensitive, so it only takes a very, almost like a breeze to get them going. So yeah, maybe this could work. That'd be exciting to see, places like this offset some of their cost and, fill in, just like with EOS Cycle and distributed wind. It doesn't all have to be 15 gigawatts to,
Right.
be useful.
Right. Well, I think that's right, Dan. It's doing things, new technology on a small scale and testing it out is really critical to advancing the technology to the next stage, which is wider acceptance of it, and publicizing the data. How well did it do? Obviously, if it does well in the O2 Arena, that's a huge publicity coup for Alpha 311 in the sense of it's visible. It's right pretty much in London, and it pokes that green energy button for a lot of people. And if it does work there and does reduce greenhouse emissions from the arena, great. Maybe do it in other places, because there are plenty of what we call soccer stadiums or football stadiums over in Europe that could do some very similar things. And it just seems like a pretty good little growth marketplace for them. So more power to them. Let's see how it plays out. That's what I really like is that, you introduce a product, you try it small scale, you show that it works, you tweak it where it needs to be tweaked, and then you can get to the next step and grow it. When you have a huge, massive output of at one time, something that's not really tested, it just typically leads to disaster long term. Very few projects actually succeed in that pathway, even though it's financially, there's incentives to do it like that. The better long term path and the longer term growth path is to do what Alpha 311 is doing. Impressive.
So last on the docket today, Digisec is a company based in Greece, and they have an interesting bird monitoring system, which I like their website. They did a good job, I think, explaining what they're doing. So number one, they're using AI to help detect birds in high-risk zones. They're doing this through both thermal imaging and high-def cameras. And then when this AI algorithm, which is scanning the imaging that's coming in, when it detects, okay, those little creatures are birds, then it can say, all right, it looks like they're coming towards us. We need to do something. So it sends out an acoustic, a noise, very directional, it says, to reduce, sound pollution, to deter the birds from coming in. And if it doesn't, then it can also stop the turbine, whether it's temporarily or whatever, to reduce any potential impacts. So, Alan, how do you feel about this? Seems pretty cool.
This is cool. It's a really cool technology. Dan, it's like if you were going to dream up a bird detection system, wouldn't this be the one that you would take a pencil to and say, yeah, this is how it would work? I would detect for a bird. I would try to shoo away the bird by some sort of noise directed at the bird. And if I couldn't make the bird go away, I would slow the turbine down and maybe even stop it, just so I don't hit the bird or get the bird too close to the turbines and do damage to the bird. It seems like it's the intuitive system. I know I've seen a lot of different, like the bat deterrent system, which seems to work on sonar effects. But this is a really fascinating, relatively simple design concept. I'm sure there's a bunch of software behind it, but in terms of its hardware implementation, it's not really complicated. But it would be like you would design on a fresh piece of paper. How would you design that system? I would design it like this. So
yeah, I see the birds, then I yell at the birds, and then the birds go away, hopefully, and if they don't, then I just go in my house. That's essentially what this is.
Yeah, it's exactly what it is. So it seems so obvious. Sometimes the best solutions are the most obvious ones, and it seems like they've gone to the obvious solution. Implementation and cost are going to be the drivers, right? How expensive is this system? Can they keep the cost down to implement it 10,000 or 100,000 times? But again, I think they're trying it at small scale, which is the best way to start. Get the data, show that it works, and then start selling the heck out of it, because there are a lot of places on this planet where you need a bird detection system and deterrent system. And if the system is reliable enough, then, man, that seems like it's a home run.
Yeah, and they said it's not just for wind turbines. It could be for airports, public spaces, wherever. But yeah, I think the question is, like, again, for a wind site, saying, hey, we have X amount of budget. Why do we need this? Like, do we have a bird problem? When do we have a bird problem? Is it 3 bird deaths a year? Is it 30, is it 30 bird deaths a year? Is it 3,000? Like, when do they decide they need a bird deterrent system? And what is that worth to them? Because it's not going to make them any money. It's just going to get, whether it's, environmental, I don't know if activists is the right word, but, people who, like the Lorax, they speak for the trees, they speak for the birds. Those who are speaking for the birds, like, hey, wind site, you're having a bird problem, can we work together to fix this? Yeah, that to me seems like the bigger hurdle. Like, why does someone say, yeah, we definitely need a bird system? I don't know. And as some of the research papers that we've shared on this podcast have said, it doesn't seem like there's a massive problem from birds, at least in some areas, right? That one paper that we talked about showed that birds were actually pretty good at detecting wind turbines and flying around them. Like, there was a massive study about birds. What was it in? It was somewhere overseas in Europe. But I don't know. So I guess that's my question is, what wind sites have bird problems? Are they aware that they're problems? And who decides that this is the threshold at which you probably need to start reducing bird deaths, because it can't be zero, right?
Right.
There's always going to be some amount probably, but
Sure.
what's an acceptable rate? I don't know. Those are all, I think, the hypothetical philosophical questions.
Well, throw it back to you this way: if you could reduce bird impacts to turbines by 90%, say it went from 100 to 10 in a year, that seems like a pretty good number to me. That it's something that's doable. Now, if it went from 1,000 to 100, there's another 90% decrease. Again, that seems like a pretty reasonable number of impact reductions that regulatory bodies will see that as something that should be implemented, right? And regulatory bodies don't always make the most engineering sense at all or financial sense at all. It just gets imposed because they feel like it. And I get it, right? It's hard to quantify the loss of a robin running into a turbine, but somebody does. I mean, someone will put a number on it and demand that it be met. How do you deal with that situation? And part of the way to deal with the situation is to be upfront and try to just to minimize the impact straight up as an industry, so you don't run into that regulatory body. If you've shown good faith effort to minimize problem areas like bird impacts by having a system that does it, and it's relatively inexpensive and simple to operate, slam dunk. I think that's a slam dunk for the wind turbine industry. It's going to happen. Going to happen.
Yeah. Well, and if you're out there listening and you operate a wind turbine site, you have experience with this kind of stuff, let us know. Shoot us an email. Tell us, what does the bird monitoring landscape look like? Is this something that people are emailing your site about? Is this something that comes up regularly? Is this, shoot us an email. We're curious to hear what your experience is. But all right, that's it. We're going to wrap up this episode of Uptime. Thank you so much for listening. Be sure to subscribe to the show wherever you're listening, on iTunes, Spotify, Stitcher, YouTube, wherever it is. And be sure to share the show with a friend. And we'll see you here next week on the Uptime Podcast. Is downtime causing you financial pain and putting a stop to your power production for months on end? It's no secret, lightning strike damage is a major cause of wind turbine downtime. This damage is preventable with our easy-to-install strike tape lightning protection system for wind turbine blades. Our incredible engineering, build quality, materials, and edge sealants withstand up to 5 times more abuse in the toughest weather and lightning conditions. And we've got the research to prove it. If you're tired of constant downtime, we can help. Reach out to us at weatherguardwind.com and schedule a free call. We'll get your uptime back in no time.